Good day, everyone. So, I welcome you to another session of Earth Science. So, today we will talk more about the underlying theories, okay, with respect to our universe and as well as our solar system. Okay, so as a recap, okay, last time we have discussed about the two governing major theories about the universe. Okay, so we have the one is the Big Bang Theory, and the second one is the creation. Okay, so we have these two theories under both the conventional paradigm and the Genesis paradigm. Okay, on the conventional side or in the science side, scientific side, we have the Big Bang Theory. Okay, on the other hand, in the Genesis paradigm, we have the creation theory. So the image on your screen tells us the differences of both theories with respect to time. Okay, as it is known that the Big Bang theory talks more about a universe that is about millions of years. Okay, while the creation theory talks about more on a uh, Earth that is more younger than it is today. Okay, so at a span of days, if we talk about the creation theory, at a span of millions of years, we have the Big Bang theory. Say, primarily, again, the Big Bang theory is the leading explanation about how the universe began. Okay, so at its simplest, it says that the universe as we know it started with a small singularity, then it inflated over the next 13.8 billion years to the cosmos that we know today. Okay? Up until such that it will expand more and more and more, and until that the components of it will be moving away from each other. Okay? While the creation is the biblical belief on the formation or creation of the universe written in the biblical context in Genesis. Okay? So, meaning that in the Genesis, in the beginning, God created the heavens and the earth. Okay, so now let's talk more about the theory that rivaled the Big Bang. Okay, so last time I've discussed about the Fred Hoyle. Okay, the one that is proposing the rival theory of Father George Lemaire's Big Bang theory. Okay, so now we have his theory and it is named steady state theory. Okay, so from the word steady state, we can distinguish that. For example, I have a pen here. When we say about steady state, it means that this pen that you are looking today is the same pen that has happened in the past, and it will be the same in the future. So, meaning, this pen won't change over time, over a period of time, or eventually forever. Okay, so this is the steady state. So, when we visualize it, it looks like this one. Okay, so on your image, we have this circle of black circle that resembles whole universe, and with this dots that represents the components, or for example, the galaxies. Okay, so as the universe expands, what will happen is the positioning will be the same, and the outsides of the universe is actually more galaxies are appearing on the spaces that has been expanded. Okay, as time goes by, it will be the same throughout. Okay, so more or less, the steady state theory, from the term itself, it tells us that the universe is in a steady state. Steady meaning it doesn't change. Okay, so when we look at this in the image, we can see that the universe is still expanding, and of course, there is always a continuous creation, but the positions doesn't change a bit. Okay, so let's try to differentiate it from the steady state from the Big Bang theory. So we have the two models here. Okay, so we have the Big Bang model and the steady state model. Okay, so with your activity, your balloon activity, that is actually the Big Bang model. Okay, so as you can see from the image, from the three image on the Big Bang model, the dots represents galaxies. When the universe expand, in the Big Bang Theory, these galaxies are actually moving away from each other. So from this point, eventually as it expands, it will be uh, going further. Okay, it won't eventually be closer. Okay, so lumalayo sila. Okay, um, if the steady state on the other hand, as it in the image, we can see that more and more galaxies are appearing. At the same time, its positioning it stays the same. Okay. So with respect to density, we can tell that if the universe in the Big Bang, the components are moving away from each other, the densities of which are actually falling. Um, when in fact, in the steady state model, we can judge that more or less it still remains the same. Okay, it remains constant as the universe expands, meaning the sides of which, when the universe expands on the steady state model, the spaces are being filled by new or more galaxies. Okay, so again, these are the two models that resembles or rival the has the rivalry at the its history, since it was stated that on that time the steady state model was uh, the one that is being approved, but it was debunked because of the evidences that we've mentioned on the our last discussion. Okay, so with the steady state model, it was proposed by Fred Hoyle. Okay, so he stated that the universe has always been essentially the same as it is today, and that it will continue that way forever. So in other words, the universe is uniform throughout space and time. Okay, so in this model of Fred Hoyle, the universe is roughly the same and uniform. Okay, at any point in time and space, from the past, present, and to the future. So it means that it has no beginning or it has no end. Okay, from any point in the time scale. Okay, so it means also that in any instant of time, the universe must look homogeneous all throughout. So steady, okay, in one line, uh, in one point of time. Okay, that is the steady state theory. So the one evidence that eventually debunked this is actually the cosmic background radiation, because the universe ruled out this theory that gave the Big Bang theory the limelight to explain the origin. Since we uh, look into it, that the simulation talks about the remnants of the heat variations that were that came from the Big Bang appearance. Okay, and it was justified again by Edwin Hubble through his observation that two heavenly objects or two galaxies that he saw that, or he observed that it is moving away from each other. Thus, the universe is actually expanding at an exponential rate. Okay, so this is the state theory of Fred Hoyle. Okay, so now let's look to another theory. Okay, so in the Big Bang theory, let's say we imagine that this Big Bang theory is the big theory. Okay, before the Big Bang, actually, so it has its component before it was stated as a Big Bang. Okay, so one of which is this one. So we have this inflationary theory. So we can see in the image, okay, that there was an appearance. Okay, this started in the step one of the Big Bang. Okay, step one after that, the growth spurt. So this inflationary theory is actually the growth spurt age of the Big Bang theory. Okay, so this theory was proposed by Alan Guth in 1981, and it proposes that there is a period of extremely rapid, exponential expansion of the universe during its first few moments. So this inflationary theory is actually part of the Big Bang theory itself, because this theory was developed to explain the several puzzles with the standard Big Bang theory. Without this explanation, the Big Bang theory is not will not be the Big Bang theory as of now. Okay, so this inflationary theory um, resembles the actual happening that had happened after the appearance of the primordial ball. Okay, so the growth spurt. Okay, so in this theory also, the first moments after Big Bang, the four fundamental forces, we have the electromagnetic force, the gravity, the strong nuclear, and the weak nuclear, were joined and resulted to an inflation. And this inflation, when in fact, is the theory of inflationary itself. Okay, so let's talk to another theory. Okay, we have this so-called oscillating theory. Okay, so what do you mean by oscillating? Oh, aka cyclic or pulsating. Okay, when we say about pulsating, it's almost the same as your if you feel your pulse. So it actually appears, then disappears. Okay, cyclic on a manner that it has been doing ever since. Okay, so periodically it is pulsating. Cyclic meaning it has an end and a beginning and an end and a beginning. Okay, so when we compare it to a type of a universe, this is actually the closed universe. Okay, so this theory was proposed by Paul Steinhardt, okay, in 2001. So simply saying that this theory means that this is a never-ending cycle from the Big Bang or from the start of the universe to the big crunch or to the end of the universe. Okay, again, the Big Bang is the start, the Big Crunch is the end, and vice versa. Okay, so the Big Crunch there is the term that's when a universe will come to an end. Okay, so this theory describes a universe exploding into existence not just once, but repeatedly over time. That's why it is called also a cyclic theory. So, for which this theory is a model of cosmic evolution according to which the universe undergoes endless cycles of expansion and cooling. So each begins with a big bang and ends again with a big crunch. Okay. So we have three underlying notions for this series. So one, the Big Bang is not actually a beginning of space or time, but rather a moment when gravitational energy and other forms of energy are transformed into new matter and radiation also. And thus, new period of expansion and cooling begins. So that is why it runs in a cycle. Secondly, the banks, quote unquote, have occurred periodically in the past. It has not happened once, but it has happened many times and will continue periodically in the future. So like for example, we have our own present time now, and eventually after billions of years or millions of years, it will eventually end. And that end comes with another new beginning again, and so on, so forth. Okay. Third is that the sequence of events that set the large scale structure of the universe that we observe today took place during a long period of slow contraction before the Big Bang. So, long period of slow contraction meaning there is a gradual change of the expansion and contraction before the Big Bang. Okay, so that the events that will occur over the next 1,000 years will set the large scale structure for the cycle to come. So eventually, we will experience this oscillating structure with this in this theory itself. Okay, so those were the major theories with regards with the origin of the universe. Now, let's move over to uh the bizarre theories when we talk about its the origin of the universe. Okay, so we have these three famous or infamous theories. Okay, on the image is we have a share icon. The second one we have the multiple of people icon, and lastly the alien icon. So we have these three theories. Okay, one is we have a holographic theory. Second, we have the multiverse, and three, we have the intelligent design theory. Okay, now when we talk about holographic meaning the a 3D object that has been presented. Okay, like for example, I have here my hand. We can see a 3D image of me that is talking to you right now on my hand. Okay, that is a holograph. Okay, so meaning our entire universe is just a hologram. So basically, we are only an experiment of someone out there. Okay. On the other hand, in the multiverse theory, meaning the universe or our universe now is not the only one. Okay, so it states that there are other universes that is existing parallel to our own universe. Okay, so it is more likely the same as the parallel universe theory. So we have many universes that eventually we can observe, but as of now we don't know it yet. Number three is we have the intelligent design theory. Okay, from the word itself, intelligent design, meaning there is always a possibility of aliens or extraterrestrial about the creation of the universe. So maybe, or more or less, we can say that there are other things, other human entities that were created or we were created by those entities, and this theory is actually an offshoot of the creationism theory. Okay, so now we will have a recap. Okay, so these are the different theories of the origin of the universe under the conventional paradigm. One is we have the model of the Big Bang. Second, the steady state, the rival of the Big Bang, the intelligent design, the inflationary universe that talks about the accelerating universe. Okay, same as with the Big Bang. These three are actually connected. The second to the last one is we have the holographic. And lastly, we have the oscillating. Okay, so those are the origin of the universe, the different underlying theories of the origin of the universe. Okay, now let's move on to our next discussion. Okay, I hope you understand the different theories with respect to the universe, because we will go now to our solar system. So we have the origins of the solar system. So let's try to define a solar system on the next slide. So by its definition, it consists of a collection of objects orbiting one or more central stars. So like our own solar system, we have our own sun that consists of the planets that are revolving around it, and some of the other planetesimals that also orbits around our sun. So that is a solar system. The components of which are materials that are revolving under its own star. Okay. So again, like the Big Bang Theory, there are two major concepts. Okay. And historically, in the solar system origins, there have been two competing classes of hypotheses or theories from the origin of the solar system. Okay, these are the dualistic or the encounter theory and the nebular theory. Okay, so we have these two theories. Okay, first we go to the dualistic. Okay, from the word dualistic, we have dual, meaning there are two stars. I have a example. This is a star that is a source star. This is the rogue star. What happened to this is this rogue star will fly nearer to the star itself, to this star. Okay. Again, what will happen to these both stars here? So eventually, both of them will pull each other up until such that the materials of each of the stars are being ejected, okay, outside its own self, meaning those materials that have been ejected will eventually be formed the planets. Okay, that is the dualistic hypothesis. On the other hand, we have the nebular hypothesis. So let's try to visualize it. So I have this pouch here. So imagine that this pouch inside uh has gases, okay, have gases. So we can see that if and only if the gases inside this pouch will be contracted, it will form its own self, or it has its own self gravity. That means the gravity will be contracted and then form a gas cloud. So imagine that this pouch is actually a cloud of gas. Up until such, because of the conservation of angular momentum, the it pulls the cloud into a disk. And eventually, in the middle portion, a central mass will form, and that will be formed, or that will be eventually our, or a star, or our sun. That is the proto sun itself. Okay, so when it happens, this proto star, the centrifugal force balances gravitational forces and a ring forms, meaning all of the things here will circulate on the central object, and that will form a large body passing around. Okay, so maybe it may have drawn some gaseous materials from it, and it will continue to spin and spin around the central star, and eventually it will become more dense, and gradually it will form planets and other planetesimas, the asteroids, comets, meteors, and other heavenly bodies. So that is the nebular hypothesis. Okay, so let's try to visualize it even further. So we have this on this image. These are the steps. Okay, again, letter A is the gas cloud, okay, from a supernova. Okay, so when we have a supernova, there is an explosion, and it will eject matter-rich pressure waves into space. So that is why, if you see a bomb or a dynamite, eventually it will be explode. All of the materials, the gas and gas, will eventually be scattered around it. So this is the gas cloud. Okay. Number two, local concentration of dust will coalesce. Okay. So meaning the rotation of the sun at the center here, we can see here at the center, this one, um, makes all the materials revolve around it and spin, thus making it that the objects or the materials are actually revolving or orbiting around its central star on the center portion. Okay. And lastly, this here, so eventually there will become a balance between gravity and solar wind, and it will continue to spin and will create these planets here. Okay, eventually it will create planets, and it will orbit around the sun as of today, and it will orbit until the end of time. Okay, so this is the nebular theory. Let's try to visualize it, okay, so that you will understand more. So I have this image here from Naruto. Okay, so as you can see, this is his Rasen Shuriken. So on the left image, we can see that there is a protostar. So this is actually the protostar, and this circling mass is actually are actually the materials that are revolving around it. Okay, so this is the nebular theory. Okay, so this Rasen Shuriken is actually depicted from the nebular theory itself. Same as with the Rasengan that resembles also the Big Bang theory. So we have that analogy for us to understand that it moves like that one, and it will projected like that one on the image. Okay, so let's move over to the different theories. Okay, same as with the Big Bang theory, it has underlying components. When the start of the Big Bang, it has the mini components. Okay. In the nebular theory, we have also components of such. Okay, that in time it formed the nebular theory. Okay, so we have this one. Okay, so this is an infographic uh, of the different theories of the origin of the solar system. Okay, so we have one, two, three, four, five, six, seven of the theories. Okay, so we have number one. This is the gas cloud theory. From the word itself, it is a gas. It is a cloud of gas by Otto Schmidt. Okay. So this theory tells us or states that gas clouds were captured by our sun due to its gravity. So we have our own sun here, and all of the materials, all of the gases there, uh, were captured by the sun because of its gravity, and which then mysteriously formed themselves and being drawn to form planets and the moons. Okay, so it means that after the creation of the universe, on the age that the universe is in its cooling phase or in the cosmic dark ages, as you've remembered, all of the remaining gases and dust were eventually created and formed into solar system. So basically, this gas cloud theory is part of the Big Bang and also in the nebular theory. Okay, second of which we have this capture theory. From the word capture, meaning uh it deals with that it has captured one thing or one object. Okay, making it such that these objects are now on its vicinity, making that these materials will then be revolving around it. So this is the capture theory of Michael Mark Wolfson. Okay. So again, this theory states that it involves the capture of a material from a light diffuse star which passed close to our own sun. So again, this is the capture theory. Third, so we have the nebular theory. So again, it is proposed by Emanuel Swedenborg. But actually, there are many scientists that has proved and has experimented this theory. Okay, and last of which is Emanuel Swedenborg. So according to the explanation, stars in the nebular theory are born from clouds of interstellar gas and dust. Okay, so let's go with the fourth one. We have the stellar collision theory of Charles Messier. So we can see that the stellar collision talks about a stellar material, a stellar heavenly body. All in short, it talks about stars. Okay, so in this theory of his, it is expected that it is the coming together of two or more heavenly bodies, which then be merged, or two body objects that have been merged and forms into a larger unit through the forces of gravity. So as its name implies, this does that the stars collided and formed planets, moons, comets, and other heavenly debris. So this is the stellar collision theory of Charles Messier. We have the fifth one again by Otto Schmidt. So accretion theory. Okay, so accretion theory, it was in 1944. It is a theory or a condensation or what we call nebular contraction. Okay, so it says that small chunks of material that separately form themselves into our planet or a moon itself. So these planets are then made of space dust and rocks that are compressed and compacted. So meaning all of these materials were slowly clustered together to form planets, and this happens when gaseous materials and thus compresses to form an accretion disk. So again, it is simply the merging of two objects. Okay, this is the accretion theory. On the sixth theory, we have the fission theory. So fusion. Fusion meaning combination, fission meaning disintegration. Okay, so this is a theory that has been discredited under George Darwin, okay, the brother of Charles Darwin. So this is now being discredited because it talks about an ancient, rapidly spinning Earth that has expelled a piece of its mass outside that formed the moon. So, so when we look at this is for example our own Earth, and it before it was spinning, okay, spinning rapidly. Okay, not the 24 hours a day. So it's spinning rapidly, meaning all of the chunks inside will eventually be expelled from it, forming our own moon itself. So all the things in the solar system comes from the sun, and it says that our sun, okay, burst one day, and all our planets came from it. Okay, same as the Earth, it is spinning through the fission theory. It formed the moon. At the same time, we have our own sun. It is spinning rapidly, and eventually all of the materials, the chunks, will eventually expelled out and will form the planets. Okay, so we have our last theory, the planetary collision theory in 2007. So this is the famous explanation on how did the moon, our moon, is in the vicinity of our Earth. So this is the prior explanation for that. So they say that the Earth was once hit by a giant meteorite, and leftover rocks created by the collision then became the moon that is orbiting on Earth. And their model suggested that at the end of the planet formation period, several satellite objects had formed and collided with the planets, thus forming moons and other debris. Like for example, diba, we all know that the dinosaurs in the past were become extinct. So one theory of that is there is actually an asteroid that has been hit on Earth. Okay, so when we visualize it, this is the Earth, this is the the asteroid, it happened that this asteroid eventually hit the Earth, and because of this collision, all of the chunks of the Earth has been expelled out, and that materials or those materials eventually formed the moon itself, and this results to the extinction of the dinosaurs itself. Okay, so primarily, um, this the planetary collision theory talks more about the creation of the moons, not only on our Earth but on the other planets. Okay, so all right, now you have known most of the theories. So with regards with our origin of the universe, and as well as our solar system. Okay, so so next meeting, we will talk more, or we will go inside our own planet. So from the universe itself, we go over to the solar system. And next week, or the next discussion, we will talk more about our own planet. So I hope that you understand the discussion, and um, see you next meeting. So that's all for today. Goodbye, everybody.